Open the map of northern Mesopotamia, and the challenge jumps out. Nineveh's palace precinct sat above a seasonal river and needed reliable water every day. Assyrian engineering answered with a regional system, not a single pipe canals from the hills. Stone aqueducts over valleys, sluices, gates, drains, and palace plumbing that all spoke the same hydraulic language. If you want one clear takeaway, it is this. The palaces of Nineveh were supply-driven machines, tuned by surveyors to a safe gradient, and protected by stone where water had to cross air. Everything else, gardens, pools, wash basins, and ritual courts, depends on that controlled fall of water across distance. The local stream could swell and shrink, clog with silt, or fail the palace in dry months. Irrigation around the city demanded volume and reliability, not improvisation. That is, ancient hydraulics in practice, engineering flow by geometry rather than pressure pipes. They walked ridgelines and valleys, reading land with cords, rods, and water levels. They looked for a gradient, shallow enough to avoid erosion, yet steep enough to keep the current alive. Where a valley broke the line, they reserved a crossing that would later become an aqueduct. Quarrymen and masons then turned that survey into structure. They faced banks with ashlar or baked brick where soils would slump. This is not Roman concrete. It is a Mesopotamian toolkit: stone, brick, gypsum, lime binders, and bitumen used where water meets masonry. The priority is continuity of section and surface, not decorative finish. Think of a long level causeway built from carefully fitted blocks with a water channel along its crown. Each course backs the next like teeth in a comb, and the channel sits within, lined and jointed against leaks. In many blocks, cuneiform inscriptions, stake royal authorship, and warn against dismantling engineering doubled as a legal fence. Why stone here? Upstream intake works drew from a reliable reach with a small dam or weir that stabilized the level. Settling basins slowed the flow so suspended silt could drop out before it entered the main line. Spillways bled off excess during storms so the canal did not scour itself to failure. Flow needed numbers, so metrology sat everywhere, just not with modern gauges. Stepfalls and check dams broke long runs into repeatable segments so crews could measure and repair with a common language. When the line met hard rock, they cut benches. When it met soft soils, they built revetments. Bring the water to Nineveh's edge, and you enter distribution architecture. Gatehouses took bulk flow and apportioned it to city channels, palace feeds, and irrigation lateral. In the palaces, drains under pavements led used water away to the Khazar or to soakaways beyond the walls. The palace is a hydraulic diagram, intake, use, and outfall all legible in stone. Inside royal precincts, water was craft and theater. Spouts carved as animal heads hid simple weirs that stabilized jet forms for ceremonies. Luxury rides on maintenance. The most prized sound in a court is water that never hammers. On aqueduct blocks you can read drafted margins and chisel fields that kept faces true. In inspection shafts, you find pick marks where crews scraped algae and silt year after year. Materials analysis confirms the craft choices you can already infer. Bitumen shows up as ribbons in critical interfaces, not as all-over paint. Baked clay pipes vary in diameter by run, with collars or sockets that take hemp and pitch to seal. Engineers also designed for failure because river systems punish certainty. Emergency spillways sat ready to take the violence of a storm without tearing the main line. Sluices were placed where gravity could help evacuate silt rather than trap it. Operations and maintenance made the difference between a royal boast and a living utility. Wardens walked the line weekly, listening for leaks, watching for burrowing damage, and marking sink points for follow-up. When a flood came, they opened spillways by routine, not by panic. Palace wastewater dropped into covered channels, then into larger, stone-lined collectors. Outlets were armored where scouring would eat banks. The same care that fed courtyards kept them dry in a downpour. Zoom out and the system becomes landscape design at imperial scale. Aqueducts are stone statements that order will cross voids. The king is present because the water is present. The claim is not metaphorical when your field's green on schedule. Was the system only practical, or was it aesthetic? Garden channels host shade trees whose roots also stabilize banks. Behind each effect sits a weir height, a lip angle, and a keeper who knows both. Comparisons help frame Nineveh's achievement without mythology. Greeks later built pressurized devices for smaller spans, but did not move such volumes across wide lowlands. Assyrian builders specialized in long, shallow lines and heavy crossings, tuned for seasonal flow and silt. Nineveh's palace water systems are Mesopotamia thinking in slope, not in pipe. Gradient drift from silt buildup, bank slumps after heavy rains, burrowing animals under embankments, joints opening under heat cycles. They designed checklists, inspect joints at outlets, rake basins for settled fines, walk embankment toes for damp spots, lubricate gates, and record drawdowns. They updated weir notches by thin stone shims rather than recutting whole sills. Archaeology keeps finding the small things that make the big picture work. A silt lens upstream of a bend shows where they should have widened the curve. Evidence is granular. Systems are made of granules. Floor gradients pull wash water toward hidden drains that disappear under thresholds. Stone lips at doorways stop sheet flow. Small scuppers release it where walls can handle splash. Choose one starting elevation, and keep your fall gentler than nature wants to give you. Segment for maintenance. Assume you will clean, patch, and open and close gates often. By the time water reached Nineveh's courts, you were looking at the last 5% of the work and the first 5% of the experience. The 90% in between is survey, stone, and supervision, the unglamorous part that keeps sound and shade alive in heat. If this evidence first tour helped you see Nineveh as a hydraulic system rather than a pile of ruins, stay with us.